Hello, welcome to the Chapter 9 videos. This chapter is about the term structure of interest rates. These are interest rates predicted to change over time, where we use the bond market to infer what the market's expected rates are. So we begin in activity 9.1 with zero coupon bonds, spot rates, and the yield curve. And the yield curve is essentially used synonymously with the term structure. So we begin by defining this chapter by defining these things. So a zero coupon bond is exactly what it sounds like. It's a bond with no coupons. So the coupon rate is zero. So essentially what you do is you're paying up front, and then you're paying a lump sum, and then you get a lump sum at the end of the term. And basically think about this as tradable lump sums. So an example of a set of zero coupon bonds are United States Treasury bills, which are also called T-bills for short, that typically mature in less than a year. So the idea basically is we could look at the market for zero coupon bonds. And while typically what we've done is we've said, well, here's the yield rate, and we price the bond to yield blah. What's the price? But what market watchers do is they look at the prices and use that to determine the yield rate or the interest rate. And this is how we see what the market predicts for future interest rates. So let's start with an example. We're going to find the yield rates as effective annual rates for a bunch of zero coupon bonds whose closing prices are given in the table, and in all cases the redemption amount is 1,000. So here's the table. So what y'all have in your book are these first two columns, and this column is blank. This is the yield to maturity, or the YTM, for each bond. So the first bond is a one-year bond. We're paying $966.18 to get $1,000 in 1 year, so that annual interest rate is 3.5%, pretty simple. For the second bond, we're paying $924.56 to get $1,000 in 2 years. So to solve for the interest rate here, we'd have 924.56 times 1 plus I squared equals 1,000. Solving for the interest rate gives us 4%. And we continued. Here we take a 1 plus I cubed, so we'd have to take the cube root after we divide. For 845.01, we take the fourth root after we divide, and so on. And so we get these yields to maturity: 3.5%, 4%, 4.25%, 4.3%, 4.325%. So I already mentioned one example of a zero coupon bond, which are T-bills. But you can create zero coupon bonds out of any bond by simply stripping apart the different coupon payments and selling them separately. So this is done, for example, through what are called the Treasury Strips program, T-strips. And what that stands for, what STRIPS stands for, is separate trading of registered interest and principal of securities. Basically, this was introduced about, looks like 35 years ago. And now I'm pausing as my heart breaks to realize that 1985 was 35 years ago. But the idea is basically exactly what it sounds like. You strip all the payments into and sell them as separate bonds. So here's just an example. You've got a 5% U.S. Treasury bond with a 3-year term, semi-annual coupons, redeemable for 1,000, and they're trading on the market according to a schedule. And you're asked to find the corresponding yield rates expressed as nominal annual rates convertible semi-annually. Right? This is a typical bond, but we've stripped the coupons and we've stripped the redemption payment, and they're selling on the market, and we're looking at their prices to infer yield rates. So as with the previous example, y'all have the first two columns, and the last column is blank. But here's what we've got. So we pay $24.51 today to get, well, the coupon rate was 5%, so that's 2.5% of 1,000. So we get 25 in 6 months. So the 6-month rate is 2%, and therefore as a semi-annual rate, or as a nominal rate compounded semi-annually, it's 4%. We answer 4%. Similarly, we've got 23.8, the price to receive 25 in 2 6-month periods. So we solve 23.8 times 1 plus I squared equals 25. Solve for I, you get 2.5%. So that's an effective 6-month rate. So to get a nominal rate convertible semi-annually, you double it and you get 5%. And we continue. And notice, in the last instance, we're not including the redemption amount, just the coupons. We're just looking at the coupons here. Right? So, and we get this set of yield rates. So these rates are called spot rates. In this case, these are nominal, annual, convertible semi-annually. We either denote them with S sub 0t, where 0 indicates that these rates are what we are looking at as of right now, or just S sub t. But with spot rates, and later we'll see forward rates, and a lot of that notation can change depending on the text you're using. So be cautious about that. Just be aware to make sure whatever you're reading, you make sense of what the notation stands for. So then when we look at this schedule of all these rates over time, as in this table, for example, that's called the term structure of interest rates. And their graph is called the yield curve. Now, we often just freely interchange the two terms. So when you hear it or see it or read it, you can think about it either way. So for each of our two examples, we can plot the interest rates and make the graphs to make our yield curve. So for the first, here's our schedule. So here's our term structure, if we're being precise. This is just exactly what we calculated in 1A. And then if we sketch the curve, you can see, it may be hard to see these dots, but you can see these dots here. Right? And so this is the curve. Right? It's not a smooth curve because it's discrete. Right? There's a value for 1, a value for 2, a value for 3, but there wouldn't be a value for, say, pi or e. We can do the same thing for the second example with our strips, and we continue, as indicated in the problem, to quote the results as nominal rates convertible semi-annually, but the times to maturity are still 1/2, 1, 1.5, 2, 2.5, and 3, and we can plot these as well. Notice it kind of flattens out here. We go 5.5 for 1.5 years and 5.5 for 2 years, but this is the yield curve for that schedule, for that term structure. Then you're asked, what do you notice? Well, what I would hope you notice is that both are increasing, and maybe the concavity, although I don't know how important that is, right? But certainly the fact that they're increasing is important because the direction the yield curve takes tells us something about about economic expectations in the market. And we will turn to that in the next video.